Hi, everyone. My name is Jules Urbach. I'm the CEO and co-founder of OTOY. For those not familiar with OTOY, we are a rendering company, and that actually is a word that means a lot of things. Our focus has been on the future of where rendering is going, towards experiences that are so real that you actually feel like you're in the real world. And for us, as we look towards the future of rendering, even just a few years out into the next decade, there are certain trends that are very clear to us. For one thing, unbiased path tracing, which is a technique that gives you physically correct rendering, is critically important. It's even more so as you get towards what the human eye can see, and that's obviously something that things like VR and AR are challenging us with screens that are eventually going to be heading towards 16K per eye, which is at a 90-degree field of view, 240 to 300 frames a second, of course, HDR. And we're also thinking that the content itself will probably change. You're going to see a trend towards live and cinematic content that is more sandbox-based than either narrative content alone or games alone. And the other thing that's going to be very clear as things such as mixed reality become normative is that holographic rendering is going to have to include relighting. So when you're trying to actually take an object or a render and blend that in with the real world, you're going to have to take that into account. And that's actually a much harder problem than just VR and even normal AR alone account for. And then the other important piece of this is that the cloud will be an important part of making this future rendering pipeline a reality. As displays on the glasses become higher and higher resolution, they become thinner, maybe even contact lenses, it's really clear that the processing power doesn't and shouldn't be on the device itself, but rather rendered on the cloud and streamed in and reprojected efficiently. So a lot of the techniques that we're showing now and that we're working on incorporate that kind of thinking. And obviously, we're here speaking at the NVIDIA booth because we are a big believer in the GPU. GPU rendering gives us a 40 times speed boost over any other form of CPU rendering. We've tested that ourselves, and our products, including Octane, are really 100% GPU focused. We are looking towards more exotic hardware for ray tracing that is interesting, and we just recently talked about our relationship with PowerVR, which has a ray tracing ASIC, which is the first validator of that kind of hardware, but that is definitely a ways off. And for now, GPU rendering is the only way that we see it getting this kind of quality and speed. OTOY's mission, holistically, is to provide the content creation tools and services that artists and developers and creators will need. And that includes things going from the capture side of things all the way to publishing content on these new devices, which is not something that has been completely resolved or is even clear. So we're trying to sort of fill in those pieces with various different products. I'm particularly proud of the work that we did last year with Oculus around Octane Vr, which was a free version of our tools that allowed users to create VR scenes and images for Oculus 360 photos. And in fact, all those 3D images were created in our tools. They were actually rendered, for the most part, on the cloud. And we created a player that is able to actually play back video versions of these, and it's something that we're going to do a lot more work on, and that's the Orb X Media Player. All that content was actually generated in about 90 days through a competition that John Carmack, myself, and Alex Ross were the judges on, and it was sponsored by Oculus. And the results were just beautiful. I mean, a lot of these users, one of the winners had never used Octane before in their lives, and they actually delivered some of these winning entries. And they're absolutely beautiful pieces of content. You can see them today on the Gear VR. You can also come by our booth and see them at even higher resolution on the ODG AR glasses. ODG is an AR partner of ours. But really, this fulfilled a lot of our goals in this first phase of providing an entire ecosystem for VR and AR. And I think that as we look forward, we want to take this further. So John Carmack actually spoke. I don't know if you can turn on the audio or if that's playing.
Basically, it was, I think, over a weekend where he generated a test image for those and sent back something that they had rendered with some of their stock content. And they have some amazing content that they can't show publicly because it's from some of their private, the media partners that they work with. Some just awesome stuff that I wish could be made publicly available. But once it got integrated into their toolkit, then we set up the Render the Metaverse contest to my goal was to try to engage artists which is we're talking mostly to programmers. Generally, when I'm up here, I'm talking to the programmers and implementers that are going to work the engineering side of things. But here we were with something that had an artist's tool as the primary interface to it. And I was excited to see what real artists would do. When you say, here's the technology, you're not messing with it all, you're pressing the button that says render to stereoscopic cube maps. What are you going to produce as an artist in this medium that really had never been done before? This panoramic composition is interesting, and quirky stereoscopic panorama is something that, as far as I know, nobody was making significant content like that. So it was interesting to throw this out and just see what people started doing with that. And I judged every single one of the issues. I felt I definitely did not feel really appropriate as an artistic judge for these things, but I went through every one of the entries that kind of met the criteria and came in, which was, there were dozens each month, so it was maybe 150 or so through all of that. And I genuinely was inspired by seeing these things where I would see these worlds that had beautiful senses of vision and composition, and I felt that it was a frozen slice from the future where I'm looking around and the quality was so good, I so wanted to be, I also wanted soundtracks. I'm sitting in these things and I wanted to hear some background music or some voiceover going on, wind blowing, because they felt so real looking at them. And I wanted to walk down that hallway or look under the bridge or do these other steps. And eventually, we'll get there.
So, that note from Carmack is actually a really important part of our roadmap. I mean, obviously, we succeeded wildly with creating stills that are at peak quality, as he calls them, for the Gear VR, which is today the highest resolution VR experience you can have. And all those things that he was touching on are things that we're working on. I mean, obviously, we want to take our tool set, our publishing system, and allow you to create that same quality on the Gear VR, but allow you to walk through those scenes and author layers of interactivity and still basically keep it as a media format. And we're exploring all of those things in the Orb X Media Player app, which will soon basically just be a library that you can incorporate into any other application on the Gear VR and on any Android platform. One of the most important things that we're showing today at SIGGRAPH at our booth is something that we believe is at the future of what Carmack is aiming for, and that is light field rendering. So it's actually not quite just light fields. It's what you're seeing here is an actual stream. And we've been working on light field viewers and players on the PC for a while. We even showed it working on Project Tango, so it works on Android. And ultimately, these light fields are really small. But what we're showing here is something even more important. This is an actual 3 megabit stream showing a live light field view. And I think that really is that combination of actually having a very efficient light field rendering and playback system, and then also being able to deliver that live over the wire was, is what we think is going to lead to the success of this kind of content. So today at the booth, you can actually see the culmination of all that work inside of Orb X Media Player on a Samsung phone. And this is a test that we made with an early version of it, and it's actually over LTE. It's streaming a light field at 1 megabit a second, and it's using the marker for position tracking. So this is the same phone that's inside of the Gear VR, and it's the same device that's going to be in the ODG glasses. And this gives you not just streaming light fields, but it gives you the ability to also do foveated cube map video streams up to 240 frames a second. So this, for us, is a really important milestone. Actually, at our booth, we're showing stereo cube map videos as well as these kinds of light field renders and the streams and other elements that you can all mix together. And all of that is something you can basically publish as a URL in Orb X Media Player, which itself can be embedded in other apps. So we think this is a really important milestone, and we're really thrilled to have this working live at SIGGRAPH. There's more, of course, to getting everything working. I mean, human face capture is an important part of OTOY's toolchain, and it's exemplified through LightStage, which is our capture technology. It's very much like a light field, publishing and rendering system in reverse. It captures 8D reflectance fields, which means that you not only get a perfect recreation of a head or a surface, but you can also relight it. So this is an old LightStage example showing relighting, and you can take a light probe and actually then get a perfect representation of that object and character inside of any environment. And when we're talking about streaming a reflectance field to a mobile device or a pair of glasses where you actually have camera pass-through, this technology becomes really important. So this is an old, early version of LightStage. The current versions that we've built are able to capture such high fidelity that you get poor level details in motion. And that was with an expensive rig from a couple years back. The latest version that we just showed at GTC this year is really exciting. So check this out.
This is Virtual Skylar, brought to you by LightStage.
So that was captured on a $15,000 rig, which is portable. And you can bring that asset into any Octane plugin, including the Unity plugin, which is coming, and you can then relight that live. And that makes this entire asset toolchain really, really, really powerful. Being able to capture human interaction in particular, along with our existing light field captures for environments, is awesome. And then we see this being part of a larger ecosystem. I mean, companies like Lytra that are genuinely advancing the art of light field video capture, very exciting to sort of imagine where all this can fit in. And it also sort of spells for us a future where interactivity and authoring of that is an important part of what we're doing as a tools company. So this is showing our current Unreal Engine integrated plugin for Octane Render, which is our GPU renderer. In the bottom, you'll see an early version of the Unity plugin. And both of these are going to be really important for the future of our rendering technology. I want to actually do a deep dive into Octane Render, which released version 3 not too long ago. Octane is an unbiased, physically correct GPU renderer. It is now, with all the tools that have been added in version 3, it's really production ready. It does everything volumetrics. With the release of Open Shader Language, we'll have the ability to really look at Octane as a framework for any sort of custom rendering that you might want to build on this. But the results are beautiful, and it's really, really amazing, even just for normal production rendering. But of course, our aim is to get this to be the toolchain at the center of the toolchain for doing holographic content. And there's a lot of pieces in Octane today that are laying the groundwork for that. So Octane 3 was released May 23rd. Our cloud rendering service, Orc, is now live. There's 2,000 users on it that are part of Orc Test Drive. And pretty much next month will be the last revision for Octane 3.0 and Orc. We'll also be testing a cross-compiled build of Octane 3.0 at that point to make sure that it actually runs on as many different hardware types as possible. And then about 6 to 8 weeks later, we'll be releasing an alpha of Octane 3.1. Today, the Octane Render Cloud service actually offers a lot of really cool features. You can actually run all of Octane entirely in the browser. We have a browser-based workflow that's integrated on the OTOY website. And within any of our Octane plugins, you can send your render jobs to the cloud. And there's literally thousands of GPUs that can be sent to your render. And we give you an integrated web experience where you can actually manage and look at those renders, publish them soon as light fields that can be then given a URL that you can then put inside of a web page or stream to the VR AR devices. The next half of our work on Octane 3 is going to be embodied in the 3.1 update, which the alpha is imminent. The alpha release in a couple of months will basically include major features that are left on our roadmap, including Open Shader Language support. We just recently, with Kronos, announced that we're seriously backing GLTF. Carmack also is a big believer in that. It's a great format. We think it's more useful than FBX, especially as a media format that can be quickly transmitted. And then we're also going to be releasing plugins for Octane. Normally our plugins have been around Octane, embedding it into other apps, but we're also now introducing a module SDK. It's now public that allows you to build pieces and enhance Octane itself. We're also going to be in the beta for 3.1 introducing adaptive sampling and headless rendering, which is going to be a zero GPU rendering option. So you can run it on Octane on a laptop and use NVIDIA GPUs that are in your office. And as we look forward to the rest of the 3.1 roadmap, we're going to have plugins and minor updates that will actually fill out everything that we think we need for Octane 3 to be useful in every capacity for production rendering and offline rendering. Some of the internal work that we're exploring in R&D is around the Octane shader compiler. We're working closely with NVIDIA on evaluating MDL, which will initially be a plugin, an Octane Orb X plugin. And then down the line, we're also considering GLSL, which is, in some sense, it can contain both MDL and OSL, for example. So it's something that we're definitely exploring in tandem with MDL and Open Shader Language. And we're also thinking about the, being able to have OSL always work and the shader compiler work on every type of platform. So we have a JIT on the CPU and also a VM for running it entirely in a sandbox. The native modules that are coming to Octane 3.1 are really, really important parts of our ecosystem. Things that we used to have to build into the renderer can now be added later in the pipeline or by others. So post effects are important, and of course denoising, which is a very hot topic in GPU rendering. We have partners that are working on those pieces. We're also working on a Substance Designer plugin, physics plugins, and even new types of script nodes that could be based on LLVM and JavaScript. The denoiser in particular is something that a lot of our customers for Octane have been looking for us to provide, and we're going to be supporting that initially with Altus as a Octane plugin. You can actually use Altus's denoising system today, but it's separate from Octane, and with an integrated plugin, it's something that you can actually use directly in Octane's workflow. It does need its own GPU, but the results are pretty great. This is 16 samples, and then with the denoiser, it's pretty much noise-free. So these kinds of results are very encouraging. And in general, we think that if you essentially allocate about a quarter of your GPU rendering power to denoising, you can get really good results with very few samples. And this, of course, is going to end up being very important as we look towards completely real-time rendering and path tracing in future versions of Octane. The other thing that we're really focused on in 3.1 towards that goal is basically natively supporting boned and skinned animation inside of Octane. This is something that we've shown in the past in Brigade. So GLTF is an important interchange format, but to support that, we are essentially deep in the Octane rendering system now now supporting skinned meshes as a primitive type, along with things like volumetric renders and OpenVDB volumes. Octane Engine, I want to touch on that. That's a zero GPU on the local machine. Basically, it is going to be our primary solution for Mac users right now, since the GPU desktop situation on the Mac isn't great. But it'll also have many other uses. If you have a low-end GPU on your workstation that maybe only has 2 gigs of memory, you can skip that and actually use Octane entirely on high-end Pascal or Maxwell cards in a box or a server. So this is going to be super useful just in a lot of use cases, even outside of the Mac ecosystem. And as we look towards wrapping up the Octane 3.1 roadmap, we're going to be focused on adding things like better displacement, new rounded edges, and a lot of tools that are built around creating workflows for light fields, volumes, and VR rendering as well, and even baking. Some of the ecosystem layers that we're adding are actually useful not just in Octane itself, but also in the Orb X Media Player. Octane Imager is one of these plugins that includes a lot of our work in post effects that allow you to do really nice compositing and relighting. There's going to be a native SDK for that, but we're also going to be providing modules that allow you to take the Octane shader compiler and reuse that inside of client applications. So one of the things that we want to support through Octane Imager right off the bat is toon shading, which you can see here. It looks really cool. There's a lot of interest in this kind of stuff. We just recently worked on the Batman animated series in VR, and we're actually using an internal version of the Octane Imager toon shader for that project. And this is also going to be really interesting when we combine things like Unreal and Unity rasterized viewports with the Octane viewport. And you can basically see that they can run in tandem even inside of both engines. And so by mixing path traced and rasterized content, you can actually come up with really interesting hybrid rendering approaches even today with these current plugins. And so Octane Imager allows basically you to fill those gaps and do things that are both in real time and offline and sort of a mixture of those two. And of course, our entire light field rendering system solves all of those things if the content can be fully pre-rendered. But on the other end of the spectrum, we really want to figure out how to get Octane's quality to run in real time on the smallest amount of hardware possible. And we've done a lot of work and research towards that goal through Brigade, which has been a totally separate path tracer that we've been developing. A lot of that technology has actually gone into Octane 3, but not all of it. So Brigade, if you guys aren't familiar with it, this is a test that we showed last year, running on about 20 nodes, and it's able to do real-time path tracing, noise-free. So that basically gives us a good sense of what's possible in real time with GPU rendering. But even one GPU, which is what I'm showing here on this video on a 980, is actually really good. It's just got noise. So a lot of our work is going to focus on how do we denoise just that one GPU's real-time path tracing system. But Brigade is very special. I mean, it's able to take these scenes even on a single GPU and deliver, if you take out the more complex shading or noise out of the equation, up to 120 hertz, which is more than enough for doing live VR rendering. You can do foveated rendering with it. And 120 hertz is clearly an important factor for VR and AR, as is higher and higher resolutions, foveated rendering. But we don't want to have Brigade not include all the things that Octane does. And Octane's obviously, in my opinion, with version 3, it's solved almost everything that's necessary for physically correct offline rendering. And next year, we're actually going to be merging the two together with version 4 of Octane Render, which we're starting on immediately after 3.1 is released. And there's already some preliminary work that we'll be doing later this year on that. So Octane 4 will include Brigade. There's going to be a new API built around Octane 4 that allows you to more deeply integrate inside of game engines as well as the existing content creation tools that Octane supports. And we're obviously really thinking about Octane 4 becoming much more of a framework than an actual rendering product itself, because we want to support almost everything that OpenGL and DirectX can do, but we want to do this with a physically correct rendering pipeline that is real time, that incorporates anything else that we can think of in that tool chain. And a big part of what we're doing with the Orb X Media Player and the Orb X scene format is actually picking what we think are likely candidates for a full open source format for this. That includes not just open shader language and GLTF, but anything that is likely to sort of provide a full scene graph for this. And we want to incorporate that in Orb X and basically have Octane 4 be a reference renderer for that system, both for real-time and offline rendering jobs. There's a lot of plugins that Octane supports, including in Motion Builder, where I think Octane 4 is going to be amazing. A lot of people want Brigade in Motion Builder, but they also want Octane, so here we'll be able to support both. And there's also, even for offline rendering, there's a lot of technology that's coming with Brigade beyond just the dynamic real-time pieces that will significantly improve our speed for noise-free rendering for offline path-traced rendering jobs. And that's one of the reasons why we don't ourselves want to focus on the denoiser. We want to get Octane itself to become noise-free as quickly as possible, and we think there's a lot of room for improvement when we mix all of this technology from Brigade into the next release of Octane. And I think that there's a lot of work that we still have to do with version 4, where we want Octane 4 to run on mobile devices. So if you want to include the Octane 4 real-time engine on a VR device that has like a Maxwell or Pascal mobile chip, it'll work really well. And that's something that we think is also on the critical path. So I want to, that's pretty much the roadmap that we have well into next year. I want to use this opportunity to maybe field any questions that you guys might have.
If you guys have any questions, I'll walk the mic over to you so we can have our speaker answer them. Just to start us off, I was wondering if you could provide some insight on Octane 4 and the impact that you think that'll have on this type of technology and, with this new technology, what people can do more.
So I think Octane 4, as I was sort of touching on earlier, is going to be a major player, I think, in real-time rendering, even on mobile devices. And it's designed to sort of allow you to target offline rendering technology for real-time use, and not just through baking or light field rendering, but also for fully real-time, dynamic path tracing. And there are technologies that are imminent, like ray tracing hardware, that will actually make this possible on a 2-watt chip. So we're excited by that, but that alone, needs also really powerful GPUs for shading and processing. So we think that, the future for wearables is going to be a combination of cloud rendering and really good local path tracing. And Octane 4 embodies a lot of that, that research and work on our part.
Thank you. Do you have any questions from the audience?
One last thing, if you guys want to see any of this running live, the light field streaming is being shown at our booth, just a little bit further down in the hall. So I'm also available to answer anything you might want to ask there.
Thank you so much, Jules.
Thank you.
Our next presentation will start in just a couple of minutes.